We are here in the clean room of the ALICE TPC, being right behind me, and I will introduce to you today the ALICE High-Level Trigger project. But before we go into details, I want to show you a few numbers which are relevant for the understanding. Just take the TPC right here. It has about 320,000 analog channels on either side, which are digitized at 10 bits and 10 megahertz altogether. That makes a data stream of 3 terabytes per second. There are other detectors in ALICE, for instance the TRD, which even produces 17 terabytes per second. This is far more than can be recorded by any existing computer system or storage system today. On the other hand, the governing principle of the physics behind is pure statistics. So many events happen quite frequently, and it's sufficient to record a certain number of them, and any more are not interesting. So the idea is to select particular events out of the overall ensemble. And this is the purpose of a trigger. It selects the data coming from all the various detectors, and in case of the high-level trigger, it does a full analysis of all events coming in. The complete processing of every bit which is recorded happens in this system. It is then produces all the physics observables, and the final analysis decides whether or not a particular event is of interest at all. That would be the trigger process, or if the event is of interest but only part of it, that would be then a selection of the data. And finally, if some data has been decided to be recorded, it is subjected to a data compression scheme in order to basically reduce excess bits and save the amount of storage for more events. In order to fulfill this compute task, massive computer resources are required. So for the full analysis of ALICE, there will be more than 1,000 processors running, and we are here in the second counting room of the ALICE HLT. The data is received via optical fibers mounted on PCI cards like this one here, where you see an FPGA, which is also used as co-processor. These cards are mounted together with another card in every computer, like this one here, which is an administration device allowing to completely manage whatever is going on inside the computer.
This is one of our nodes. I will now show how to insert one of the FPGAs. There are already 2 of them inside, and here are the fibers from the experiment. And here is our administration card.
So I present you the online display of the high-level trigger in ALICE for the TPC detector. Here we see a proton-proton simulated event at 14 TeV energies and 0.05 Tesla. With this display, one can zoom on the TPC volume and choose to analyze a track property during the online data taking.
This project is carried out by collaborators across the world, from institutes in Heidelberg, Frankfurt, Bergen, Kolkata, Oslo, Calgary, and last not least, Cape Town.